introduce the concept of graph. In this video, what we are going to do is we are going to look at different operations that can be applied on the graph data structure. In the last video, we have looked at two different implementations of the graph: array implementation and linked list implementation, also called adjacency matrix and adjacency list implementations respectively. So the way we are going to proceed in this video is that first we are going to look in the object implementation of graph as a data structure. We also look at some of the basic operations, like given a particular vertex, I want to print all the vertices that are adjacent to that vertex, right? Or given two vertices, I want to implement a function that returns true if these two vertices are adjacent, and it returns false if these two vertices are not adjacent. Alright, so these two are very basic operations. Then we are going to look at the traversal operations. How do we traverse a graph? By traversal, we mean that visiting each and every vertex of the graph, because there are multiple routes of going from one vertex to another vertex. So we will consider all the edges during the traversals. So the two rampant traversals of a graph algorithm are BFS and DFS. Breadth first search and depth first search algorithms. We will look at both of these algorithms, right? And then we will look at some of the questions that apply directly or indirectly the operations of the graph, right? Not necessarily on the graph itself. They may be applying these operations on either a binary tree or a matrix, but the operations are similar to BFS and DFS. So let's start with the code. So we are taking the same question कि Facebook users हैं और वो friends हैं. For example, I have users A, B, C, D, E, F, G and H. So there are 8 users. 8 users हैं और वो 8 users, they are all friends, right? So we have taken a very practical scenario where A is friend with B and E, B is friend with only A, E is friend with A and C, C जो है he is friend with A, E and F, F is friend with C, D and H and so on. Right? So in the last video we have looked at how we implement it in an adjacency matrix representation or the array implementation. तो पहले तो हमें एक vertex array बनानी पड़ेगी. Vertex array में we will assign a number to the user. So user number A is number 0, B is number 1, C is number 2 and so on. So all the users are assigned a unique number. So whenever I say 0, 0 का मतलब है A. Whenever I say 1, इसका मतलब है B and so on, right? So when we represent it in a matrix, so matrix की form में there is one row for each user and there is one column for each user. So cell ij will be true. Cell ij will be true if user at I is friend with user j. तो यहाँ पे 0 is 1 are friends, 0, 4 are friends. 0 is A, 4 is E. A, E are friends. And friends are represented by edges in the graph. Right? So we have edges which represents connection and we have vertex which represents users. So users are connected or users are friends if there is an edge between two users. Alright? तो इस मैट्रिक्स को अगर हम ढंग से देखें तो this matrix has 64 cells. This matrix has 64 cells. Out of these 64 cells, practically we are using 1, 2, 3, 4, 5, 6, 7, 8. We can do with only 8 cells. अगर हमें 8 cells की वैल्यू दी हुई है 1, 2, 3, 4, 5, 6, 7. In fact 7. 1, 2, 3, 4, 5, 6 and 7. Sorry, this cell is false. This cell is not true because F is not friend with G. F or G those names. Right? So we are using practically 1, 2, 3, 4, 5, 6 and 7. So we are using only 7 cells. 7 cells. Why? Because अगर इस मैट्रिक्स को हम देखें तो ये मैट्रिक्स सिमेट्रिक है क्योंकि हमारा जो ग्राफ है वो अनडायरेक्टेड ग्राफ है. अनडायरेक्टेड ग्राफ है, मैट्रिक्स सिमेट्रिक है, तो लोअर ट्रायंगुलर ऑफ द मैट्रिक्स is exactly same as upper triangular matrix. तो अगर हमें 4, 3 की वैल्यू निकालनी है तो हम 3, 4 की वैल्यू निकालेंगे एंड दे विल बी सेम. तो हमें 4, 3 को स्टोर करने की जरूरत नहीं है, हमें 5, 2 को स्टोर करने की जरूरत नहीं है बिकॉज 2, 5 has the same value. Right? So we can just remove these and we can just use these. Okay? So in the matrix, we are actually using only 7 cells. We are not using many cells. We are just using 7 cells. But the memory allocated is for 64 cells. So the occupancy level is around 10%. और जैसे जैसे ये बड़ी हो जाएगी, अब if you consider Facebook, so there are 1 billion users. If there are 1 billion users, and on an average, one user is friend with 1,000 other users, so this occupancy will be around 5% or 1% or 2%. It will be very less, right? So it's a very sparsely populated matrix. So the second thing that we can do is we can use the linked implementation. So in case of linked implementation, what we do is the following. जहां जहां पर मैट्रिक्स खाली है, और बाय द वे खाली में फॉल्स स्टोर करने की जरूरत नहीं है, बिकॉज इफ इट इज नॉट ट्रू देन इट इज अज्यूम्ड टू बी फॉल्स, राइट? तो जहां जहां पे भी ये खाली है वहां पर आई एम जस्ट रबिंग इट. So let me just rub it. Alright, so I have just rubbed the black part of it, right? So 0 means 0 is connected with 1. So instead of 0 we can just write the name, right? So let me just write the names A, B, C, D, E, F, G and H. And we know that A represents 0, 1, 2, 3, 4, 5, 6 and 7. Alright? So it is like this. अब क्योंकि हमने बीच में से होल्स को हटा दिया है, तो ऊपर वाली रो की कोई सिग्निफिकेंस नहीं बनती. ऊपर वाली रो को अगर हम हटा दें तो ऊपर वाली रो एक्चुअली रिप्रेजेंट्स this true actually represents that A is friend with 1. So I am just replacing true with 1. True 1 हो गया, ये 4, this will be 4, this is 5, this is again 5. So we are just replacing true with the number that is there in the column. True जिस column number में है हम उसके साथ true को replace कर रहे हैं. This was 7, this is also 7, then 6, 5, 0 and 0. And then I am just connecting them. So 1 का next part is 0 का next is 1, next is 4. B का next is 0, C का next is 4, 4 का next is 5, 5 का next is null, 4 का next is null, 0 का next is null, right? So D का next is 5, D का next is 5, E 0, then 2, 2, 3, 7, G 7, this और बाद में null, right? So if you look at it, what we have done is that we have changed the adjacency matrix representation to the adjacency list representation, right? There are two types of nodes in this list. One are the nodes which are red, these nodes, alright? So one are the nodes जो ये black color की nodes है, और दूसरी ऐसी nodes है जो ये red color की nodes है, right? By the way, how much space is required now? Now it is consuming how much space? तो जितनी हमारे पास edges है, उन edges का डबल लगा लो, क्योंकि A जो है वो B के साथ कनेक्टेड है और B जो है वो A के साथ भी कनेक्टेड है, right? So if I have E edges, then there will be 2E nodes, right? For each edge AB, I will have a node for AB and for BA, क्योंकि ये अनडायरेक्टेड ग्राफ है. डायरेक्टेड ग्राफ के केस में अगर मेरे पास E edges हैं तो नोड्स भी E ही होंगे, right? I can rub this now. So we are talking about directed graph. Directed graph के cases में if there are E edges, then the total number of red nodes will be 2 into E. Each red node has how much memory? हर एक रेड नोड में 2 यूनिट मेमोरी है. पहला यूनिट मेमोरी एक इंटीजर वैल्यू स्टोर करने के लिए और दूसरा यूनिट मेमोरी एक पॉइंटर को स्टोर करने के लिए. So each red node consumes 2 unit of memory. When I say 2 unit, हो सकता है कि if 1 unit is 4 byte, then 8 bytes. If 1 unit is 8 byte, then 16 bytes. If 1 unit is 1 byte, then 2 bytes, right? So each node consumes 2 units of memory. There are total 2 into E nodes. So the total amount of memory consumed by read nodes is equal to 4 into E. So 4E is the memory consumed by read nodes, and black nodes. So in case of black node, we require one node for each vertex. अगर V vertices है हमारे पास, if we have V vertices, then we will require V nodes. So black color की V nodes create होंगी, और हर एक नोड में एक तो पॉइंटर स्टोर होगा which is pointing to the head of the red list, एक नेम होगा, right, और एक उसका नंबर होगा. So let us say it is consuming let us say that each node of X consume X amount of memory. Then the total memory required will be X into V, which is again some constants. So the total memory consumed by this linked list is on the order of V plus E. We add these two values, constants बाहर चले जाएंगे. So the total amount of memory consumption is on the order of V plus E. Now V plus E is a linear memory consumption. Matrix के केस में जो memory consume हो रही थी वो on the order of E square हो रही थी. So on the order of V square. On the order of V square हो रही थी, right? So this is a quadratic consumption. On the order of n square से हम on the order of n पर लेकर आ गए memory consumption को. Obviously we will have to look at on the case by case basis, क्योंकि यहाँ पर E से independent है ये number of edges पे depend नहीं करता, और इस केस में memory consumption जो है वो number of edges पे depend करता है. So if our number of edges are close to on the order of V square, so even this will consume on the order of V square memory, right? So if we have n vertices, then this is going to consume on the order of n square memory, and this is going to consume on the order of n plus on the order of E, where E is the total number of edges. If each and every node is connected, then the number of edges will be on the order of n square itself. So we don't gain anything in the memory, in terms of memory, right? But in this case, we are gaining a lot in terms of memory because the total memory consumption has reduced substantially. Alright? So we need to define two classes, or if we talk in terms of C language, then we need to define two structures. One structure to store black nodes and one structure to store. One is the class that represents this node. So this node I am calling it a neighbor node, right? Right? So class neighbor. Or let me just call a connection class, right? So class connection. Connection class has one integer and a pointer to the next node, which is of the same type. So it has one integer, which is a vertex ID, and next is a connection pointer. Similarly, we have a class vertex, which represents this particular node. Right? And there will be functions in this class. So there will be multiple functions here, there will be multiple functions there. If you are using Java, then also you will be using a similar thing. So you will have a connection object and you will have a connection object next, right? So by object I mean reference. So you will have a connection reference next and a connection reference head, right? So every vertex has an ID, like every vertex has an ID. Every vertex has a name, right? So there is a name. Connection has a vertex ID to which this connection represents. So vertex ID and ID here, they are like a mapping between two classes, right? And finally we have a graph class. In this graph class, what we have is the list of all the vertices. So we have an array of vertices, right? So we have a vertex array, and so on. Okay. So this is the implementation of this is how we designed this. This is how we have designed this, right? So there are three classes, one representing this, one representing that, and then a graph class. If a user want to instantiate a graph, then he just need to create an object of the graph class, and probably this array, vertex array, need to be a variable length array whose length is defined in the constructor of the graph, and we just need to implement certain methods inside this graph class.